Hey, see Miss G, here's the warm-up answers. So you want to make sure that you're checking your answers after every section. I'm going to include the links in the section this time for you guys, and so it can be easier to find the videos for you to check your answers. So now for number one, consider the graph of a line. Which equation has a rate of change greater than the rate of change for the line shown? So we have to understand that the rate of change is the slope. So we have to figure out which of these slopes are greater than this slope. So this is written in y equals mx plus b. So you can see that the slope is going to be the number in front of the x. So here the slope is 3. Here the slope is 1/2. Here the slope is 3/4, and here the slope is 2. And so we got to figure out what the slope is from over here so we can compare it to here and see which one is bigger. So now remember that slope is rise over run, and the rise of this graph is going to be up. So let's look here. So we can start here. This is a good point. It's on a corner. So the rise is 1, 2. The run is 1. So this one would be, so rise over run for this one would be 2 over 1, or just 2. So now we can go back here and we can check to see which of these slopes are bigger than 2. And you can compare and see that only this one is bigger than 2. Don't get confused over here because this is equal to 2. That's not bigger than 2. Okay, so now I have to explain our reasoning. I found the slope of each line, each equation, and then I determined the slope of the graph, which allowed me to compare each compare them. Okay? That's a good way, because you gotta think of it like this. There's a saying that says compare apples to apples, oranges to oranges. So this is a graph. These are not graphs. These are equations. So you gotta make sure that you can figure out, you could have made these into graphs and compared them, or you could have made this into an equation and compared it, which is what we did. So you always make sure you're comparing it apples to apples, orange to oranges. Graphs to graphs, equations to equations, whichever is easier in the case. Okay. For number 2, what is the length in units of the line segment A prime B prime in the resulting figure? Okay, so let's look at number 2. Rectangle ABCD is rotated by 90 degrees clockwise about the origin, then translated 3 units to the left and 2 units down, form A prime, B prime, C prime, D prime. And so we're looking back at the question, what is the length in units of the line segment A prime, B prime in the resulting figure? So we can see, if you remembered, that dilations are the only transformation that changes the size of the shape. So was there any dilations performed? If that's a no, then the size of the shape would stay the same. So A prime, B prime should be the same as AB, which is here. So let's look at this again. Rectangle ABCD is rotated by 90 degrees clockwise about the origin, then translated 3 units to the left and 2 units down to form A prime, B prime, C prime, D prime. There was no dilations performed, so therefore the size would not change. So A prime, B prime would be the same as AB, which is 1, 2, 3, 4, 5 units long. So 5 units is A prime, B prime's length. Okay, so we're almost done with the warm-up. Now, for the last one, solve the equation 12x minus 1 equals 3x minus 7. Okay, so let's do this real quick, and I'm going to use my new tool that I got for you guys, because it's going to be easier for me to do it this way. You guys can always just write it down, type it in to show your work. but I'm going to write it this way to make it easier on me. Okay, so solve the equation 12x. Solve the equation 12x minus 1 is equal to 3x minus 7. So we want to isolate the variable, so we're going to add 1 to both sides. Then we're going to have 12x minus 1 plus 1, 0, bring down the equals. And then 3x plus 0 would be 3x. And then minus 7 plus 1 would be minus 6. Okay, we're almost isolated the x. So now we're going to subtract the 3x. Subtract 3x. And 12x minus 3x is 9x. And then 3x minus 3x would be 0. Bring down the equals. And then, oh, we don't need that 0 though. Let's erase that. We can just, and then bring down the minus x. And then divide by 9 to get the x by itself. So you can see x is equal to negative 6 over 9. Okay, so negative 6 over 9 there. Okay, thank you guys. That's the answers for the warm-up. Make sure you're checking your answers after each section.